What would happen if astronomers announced tomorrow that an asteroid was heading toward Earth? Would we panic, prepare, or launch a mission to stop it? Fortunately, we don't have to guess. Around the world, scientists, engineers, and disaster planners are running detailed asteroid impact simulations, scenarios designed to help humanity prepare for the ultimate planetary emergency. At Infinity Beyond, we take you inside these simulations to explore how the world would respond, what tools we have, and how close we are to being truly ready. One of the most famous exercises is the WOW Hypothetical Impact Scenario, developed by NASA's Planetary Defense Coordination Office. These simulations are run at global conferences like the HOT Planetary Defense Conference, where international experts are given a fictional asteroid on a collision course with Earth and asked to respond in real time. Each day of the simulation, new information is revealed: the asteroid's size, speed, composition, and potential impact zone. Participants must then decide: do we launch a deflection mission? Do we evacuate cities? What are the legal, political, and ethical consequences? It's not just a game. These simulations reveal how critical it is to have clear communication, international coordination, and public education. They show how every hour counts and how quickly the situation can change. One key lesson: if the warning time is short, less than a year, there may not be enough time to divert the asteroid. Instead, focus shifts to disaster response and home civil protection. Scientists model potential impact zones using tools like Purdue University's Impact Earth Simulator, which calculates crater size, shockwave radius, and thermal radiation zones based on asteroid parameters. NASA's JPL Sentry System, which continuously monitors known near-Earth objects, NEOs, for potential future impacts. ESA's NEO Coordination Center, which works with telescopes across Europe to track and simulate asteroid trajectories. But preparation isn't just about computers and models. It's also about people. Cities and nations need impact response protocols, evacuation plans, emergency communications, backup infrastructure. Hospitals must be prepared for blast-related injuries. Governments must coordinate international aid and logistics. In 2021, FEMA, the Federal Emergency Management Agency, and NASA ran a joint simulation where an asteroid was discovered with only 6 months warning. The result? Not enough time for deflection. The exercise shifted toward assessing which populations could be evacuated, how to disseminate reliable information, and how to prevent panic. One unexpected challenge in these simulations is misinformation. In a real-world impact scenario, social media could spread fear, false claims, or conspiracy theories. That's why scientists emphasize the importance of trusted communication channels: scientific, transparent, and unified. And what about the tech? If given enough time, 5 to 10 years, missions like DART, Double Asteroid Redirection Test, could be launched to nudge the asteroid off course. Backup options might include multiple kinetic impactors, gravity tractors, or even nuclear deflection. But what if the asteroid is too large? Or if it's a rubble pile, a loosely held cluster of boulders that absorbs impact instead of deflecting? Simulations test all these possibilities. Engineers create 3D models to analyze how different asteroid structures behave under stress. They test how spin, porosity, and shape affect momentum transfer. These models inform how much force is needed and what kind of spacecraft to build. Even student teams now participate in these simulations, designing mission profiles, calculating fuel needs, and presenting ideas at space conferences. The goal is to create a new generation of planetary defenders. Because planetary defense isn't science fiction anymore. In 2022, the DART mission proved we can alter an asteroid's orbit. In the next decade, more missions will test and refine these capabilities. But we're still early in this journey. Simulations also explore post-impact recovery. If we can't stop an asteroid, how do we rebuild? What support systems need to be in place? How do we feed, shelter, and treat survivors? In some simulations, a mid-sized asteroid hits the ocean, creating massive tsunamis. In others, it strikes a remote region, but causes a dust cloud that cools global temperatures and disrupts food production. These scenarios explore how resilient humanity truly is and what infrastructure needs to be strengthened now. Some of the most advanced simulations even incorporate artificial intelligence and machine learning, using real-time data to update predictions and suggest the best mitigation plans dynamically. So where does this leave us? Better prepared than we were 20 years ago, but not invincible. The good news? Scientists, engineers, space agencies, and emergency managers are taking this seriously. Simulations are driving innovation. Policy frameworks are being drafted. Public awareness is growing. At Infinity Beyond, we believe in the power of preparation. Simulations aren't just theoretical. They're dress rehearsals for the real thing. They reveal weaknesses, highlight solutions, and empower humanity with knowledge. Because when it comes to asteroid impacts, doing nothing isn't an option. We may never face a catastrophic impact in our lifetimes, but if we do, the difference between survival and disaster could be the simulations we run today. Stay alert, stay informed, stay beyond.